Hello and welcome back to New Pewaukee YouTube channel video. Today's video we're going to be taking a look at one of the ways that you can get better at Leetcode. So I've just kind of discovered this myself and kind of been rolling with it because I think it makes sense, and it's kind of batching your problems by topic. So if you enjoy this video, make sure to like, subscribe, comment your favorite thing, or how I can improve my code. So the idea behind this is that you should do the Leetcode topics you can see here, right, of each problem. So we should start with easy problems, and we should say, okay, let's solve two-pointer problems. So this problem I've solved before, a while back, in January, actually, and that was 2020. But anyways, I solved it a while ago, and it's a two-pointer problem. So now, after solving those easy two-pointer problems, we want to get into the medium two-pointer problems. So those are the problems we're going to be talking about today in this Leetcode kind of. We're going to be covering two questions. We'll call it like a Leetcode recap, perhaps, and we're going to discuss these two questions. So, the first question is container with most water. So, you can read the question. You're given an integer array height of length n. There are n vertical lines drawn that such two endpoints of the ith line are I, 0, and I, height I. Find two lines together with the x-axis to form a container, such as the container contains the most water. So we're looking for the largest rectangular area where the kind of length or the height of the rectangle is determined by the height array that is the least. So for example, we have this red one on the right is less than this red one on the left, and that determines the height. So this is going to be a two-pointer approach. It's going to be an opposite directional two-pointer approach. So we're going to have a left pointer here and a right pointer here. You can also feel free to look at the code and understand the idea. So, what we want to say is that, so right now we have this big distance apart, right? But we want to try and optimize it so that if the left value, so let's draw a little, so this is our current area right now, kind of shaded in yellow. If that area is less than, or I mean, we're just finding that area, right? That's the general idea, first of all. And if the area is greater than the res, right? So the current res, or result, is 0. That's what we initialized it to. But now, with this area, it's 8. So 1 times 8. And then what we want to do is, we want to say, okay, whichever one of these is smaller, left or right, so either left or right, if the minimum value is the left one, so that means if the left value is less than the right value, then we want to increment the left pointer, right? So the idea behind that is that we want to get both pointers to be the highest value as possible, right? So we want this left value to be higher, right? Because right now it's lower than the right, so we don't want that. So we have to iterate through every we need to keep going in until the left is equal to the right. So basically, the left is going to go here to start. So I'll say this is L1 and R1. So next, we'll move to L2. And, this is our max area, but technically we don't know that yet, right? Because in theory, the idea could be that we have two really, huge height I values, and, their length might be 1, but their height is like infinity. So the answer would be like infinity, just as an extreme case, although, that's beyond the, constraints of this problem. But, so let's keep going. So we will have L2, right? And then we'll realize that, okay, R1 is less than L2. So now we will say R1, go here. And then again, this should be 2, R2. Then again, R2 is less than L2. So we're going to say R3. So now they're equal. So really it doesn't matter which one you move. So we can see here that in this code, we are saying that the min value, first of all, is the minimum of the two heights, or the two indexes, of the 2 pointers, right? Of the values, the minimum value of the 2 pointers, to which value they're pointing to, right? So the minimum value, if the minimum value is the left one, then left plus equals 1. If otherwise, we're just going to say decrement the right. And so the idea here is that min, when given 2 arguments, it doesn't really even matter which one will be less. That makes sense. So it might be height left, or it might be height right, but it actually doesn't matter if they're equal, because it doesn't matter which way Python interprets this. So this may be true, or this may be true. I'm not really sure how Python interprets it, but it doesn't matter. Let's say we decrement the right. So we say R4. Now R4 is infinity. So L2, or let's just say in this problem, L2 is infinity, right? So we would say then L3, and then L4, and then we would go to L5. And then the next iteration, we wouldn't actually do anything, right? Because then they'd be equal. So we wouldn't want to say like R5. That doesn't make sense, because then you'd have a kind of one-dimensional line, and you can't evaluate the area of that, right? So over all these iterations, we would get all the possible areas, right? By doing area equals min value multiplied by the distance, which is right minus left. And then we would eventually get, I guess I didn't update this res value, but we would eventually get, was it 49? Whoops, not 50 something. 49. So that's the general idea for this problem, is that we just want to we want to say which one is the min value, and then we want to gamble, right? We want to decrease our length so that we can hope for an increase in height, right? So for example, here, going this way, right? We decrease the length, so the length becomes -1, but we hope for an increase of height. We hope for something like this, so that we can get a kind of bigger area, right? Obviously that doesn't happen, and we just keep iterating. And that's basically the idea for this problem. Now let's go over one last problem. 3-sum closest. So, given an integer array nums, length n, and an integer target, find 3 integers and nums such that the sum is closest to target. Return the sum. These 3 integers. And you may assume that each input would have exactly one solution, right? So we would want to say, so first thing I do is sort. So using Java this time, so we're just going to use arrays.sort nums. And then we're going to say int close equals integer.max value. Basically what this means right now is the distance. So let's say in our example we have -1. Yeah, I'll come. 5 minutes. So we have this array, right? Let me get the brackets off. So the idea, right, is that you want to find the closest distance to the target, right? So, or the least distance to the target. That's the idea, right? So let's say you had, let's say you had something a little bit bigger, and it was sorted. So let's say we had -1, 0, 2, 4, 6, and 10. And let's say the target equals 5. So now we can kind of use the 3-sum idea, which says that we should fix an x value. And then we should treat this as a 2-sum problem, which basically means that, so this is the left pointer, this is the right pointer, so we have 2 pointers. And basically we want to try and either decrement R or increment L. in order to get the optimal value. So that's the idea that we're going to use, because we want to say, okay, if we want to get the sum, right? So we get the sum, and then we say if the sum is equal to the target, we return the sum, because that would be the closest thing. So for example, if this was 8, no, if this was 12, then we would say 0, 2, and 10. So we would just return that, because we've found the closest thing possible, which is 0, units away. Instead, we would say that the difference is equal to the negative target minus sum. So what does that mean? So let's say, for example, we initialized x to be 0, L to be 1, and R to be 5, right? The indexes. And we said negative 1 plus 0 plus 10 equals negative, or 9. Whoops, 9. So the idea behind this is that this is plus 4 away from 5. So that's what we want to store in close. So it's positive 4 up, right? So that's what this does. This says minus 5 minus 9. And then, it is just negative 4. In theory, this could instead be something like sum minus target, which makes a little bit more sense now. But, the general idea is still the same, I guess. So it's just 5 minus 9 to be plus 4. And then what we want to say, right? We want to get the absolute value of this current difference that we've stored as in our to_sum. And we want to say if that absolute value of the difference is less than the absolute value of the close, then we want to say that the close equals diff. No matter if it's positive or negative, it doesn't matter. Because basically if we had positive 4, then if we had negative 3, so for example, if we had a sum that was equal to 2, well, this would be negative 3 away from 5. But then again, 2 is still closer to 5 than 9 is to 5. So we would want our result to ultimately end up being 2. So we would store close to be this negative 3. So we'd say that's close, right? Because it's negative 3 away. So then, in continuing with the to_sum philosophy, where we do the decrement L, or decrement R, or increment L, if the difference is less than 0, right? So that means that if it's this, right? That means that this 2, for example, is pretty small. Obviously this 2 is less than 5. So that means we want to increment the L to give a higher value so that the next sum can be greater. So for example, if we had 9, right, in the first iteration, so 9 was greater than 5, right? 9 was greater than 5. So since it's the difference, which was positive 4, is greater than 0, we want to decrease the sum. So we want to bring R to be here. R1, for example. We'll say this is the initial, and this is the initial. And so now it's brought to R1. So now, when we sum, we're going to get negative 1 plus 0 plus 6, which equals 5. And we are going to get, we are just going to return that 5, for example. So in this example, I guess we had a nice kind of sum like that, and we didn't have to iterate any further, and that was a quick compilation of that example. So that's the general idea, is that we want to take this 2 pointers with the sorted array, and we want to say, okay, if the difference is too high, that means that we need to decrease our sum. So we need to put the right pointer down. We need to decrement the right pointer. For example, or on the other hand, if the difference is less than 0, if it's negative, that means that the sum was smaller than the target, and we want to try and get as close to the target as possible, right? So we want to try and increase that sum by incrementing the left pointer. And as we keep going through these iterations, like for example, we would have in the future, as we would keep going, we would have this would be x. Yeah, this would be x, for example. This would be like the initial left pointer. This would be the initial right pointer. And we would still try and make those comparisons again. So that's how this iteration would keep going, right? The x would keep incrementing, given this for loop, and setting the x equal to the nums I, it would keep incrementing. And then it would go through all the elements in the array. So instead of something like O n third, which we would have if we just iterated with 3 pointers, right? Instead, we have O n squared, I think. Yes. That would be, I think, the worst case. But even then, you know, this left and right pointer distance kind of decreases as the list goes on, right? So the length of the kind of subarray decreases as it goes on, but technically that's still O n squared. So we're able to reduce the complexity by, 1 power. Oh, and then finally, we'd run a return the close plus target. So for example, if, let's say +4 was the closest thing we got, then we would want to return 5 plus 4, which was 9. So don't worry about these elements, but let's say the closest thing we got was +4. Then we would want to return +4 plus 5, right? Because we're returning the number that was 4 up from 5, the target value. So that's the idea of the return statement. I hope you enjoyed this video. I think my drawings were fun, and I think I might try and keep that up as I solve more 2-pointer problems and give you more tips on how to improve at Leetcode, as I am desperately trying to improve myself. Thank you very much for watching the video. Hope you have a good night or day. I'll catch you in the next one. Oops, if I can actually get out of the video. I don't know that I can. Oops, that's still the wrong one. There we go. See you later.